welcome to iasvideos.com. For remaining 80% of today's video and for previous videos, subscribe to us on our website. 6. The sun shines on India's Aditya. This topic will be important under General Studies Paper 3. Indian Space Science and Space Exploration Missions. Why recently in news? Indian Space Research Organization, ISRO, is planning to launch its Aditya-1 satellite for the Sun in 3 years, but with a few changes from the original plan of the mission. ISRO chairman on Monday said that there will be a change in the scope of the mission designed to study the Sun's corona. We realized that we can put the satellite in an orbit from where it can see the Sun continuously, hence increasing the observation time, he said. About mission Aditya-1. ISRO initially planned to put the 200-kilogram satellite into an 800 kilometers orbit in 2012-13 to coincide with the solar maxima. The current plan is to launch the satellite between 2017 to 2020. ISRO website suggests that current plans envisage placing the satellite in a halo orbit around L1 Lagrangian point of the Sun-Earth system to facilitate continuous viewing of the Sun without any occultation, eclipses. Technical studies have established that a PSLV-XL launcher would be able to place a satellite at a halo orbit around L1 point. Objectives of mission Aditya-1. To study the coronal mass ejection, CME. To study the crucial physical parameters for space weather, such as the coronal magnetic field structures, evolution of the coronal magnetic field etc. To determine why solar flares and solar winds that disturb the communication network and electronics on Earth. To use the data from the satellite to better protect its satellites and spaceware from being damaged by hot winds and flares ejected out of the corona. Satellite instrumentation. The mission contains following 6 instruments. Visible Emission Line Coronagraph, VELC, IIA, Bengaluru. Solar Ultraviolet Imaging Telescope, SUIT, IUCIA, Pune. Plasma Analyzer Package for Aditya, PAPA, SPL, VSSC, Trivandrum. Aditya Solar Wind Particle Experiment, Aspects, PRL, Ahmedabad. Solar Low Energy X-ray Spectrometer, SOLEX, SAG, ISAC, Bengaluru. High Energy L1 Orbiting X-ray Spectrometer, HEL1OS, SAG, ISAC, Bengaluru. Structure of Sun core. The core of the Sun extends from the center to about 2025% of the solar radius. It has a density of up to 150 grams/cm, about 150 times the density of water, and a temperature of close to 15.7 million Kelvin, K. Energy is produced by nuclear fusion in the core region through a series of steps called the pp, proton-proton, chain. This process converts hydrogen into helium. The rest of the Sun is heated by this energy that is transferred outwards through many successive layers to the solar photosphere before it escapes into space as sunlight. Radiative zone. The Sun's radiative zone is the section of the solar interior between the innermost core and the outer convective zone. In the radiative zone, energy generated by nuclear fusion in the core moves outward as electromagnetic radiation. The temperature drops from approximately 7 million to 2 million Kelvin with increasing distance from the core. Tachycline. The radiative zone and the convective zone are separated by a transition layer, the tachocline. This is a region where the sharp regime change between the uniform rotation of the radiative zone and the differential rotation of the convection zone results in a large shear condition where successive horizontal layers slide past one another. The fluid motions found in the convection zone above slowly disappear from the top of this layer to its bottom, matching the calm characteristics of the radiative zone on the bottom. Presently, it is hypothesized that a magnetic dynamo within this layer generates the Sun's magnetic field. Convective zone. In the Sun's outer layer, that is 70% of the solar radius from the center, the temperature is lower than in the radiative zone and heavier atoms are not fully ionized. As a result, radiative heat transport is less effective. The density of the plasma is low enough to allow convective currents to develop. Material heated at the tachocline picks up heat and expands, thereby reducing its density and allowing it to rise. As a result, thermal convection develops as thermal cells carry the majority of the heat outward to the Sun's photosphere. Corona. A corona is an aura of plasma that surrounds the Sun and other celestial bodies. The Sun's corona extends millions of kilometers into space and is most easily seen during a total solar eclipse, but it is also observable with a coronagraph. The Sun's corona is much hotter than the visible surface of the Sun. The high temperature of the Sun's corona gives it unusual spectral features. The outer edges of the Sun's corona are constantly being transported away due to open magnetic flux generating the solar wind. Forbidden or hot spectral emission lines and is the main source of information about the corona's composition. 7. The first long-haired ones. New WASP group proposed for 5 new species from India. This topic will be important under General Studies Paper 3. New scientific discoveries. Why recently in news? 5 new species of wasps have been discovered in parts of India. Indian researchers Veena Kumari Kamalanathan, Prashanth Mohanraj and F.R. Khan of the National Bureau of Agricultural Insect Resources have named the 5 species as Adhika showers. The Sanskrit word means first one to have long hairs. Because of their uniqueness and their strong resemblance to each other, as well to aid taxonomic studies, they have been considered as constituting a group of their own. Features of newly discovered wasp species. All of these species have one common distinctive feature. They have long hair-like structures that extend from both of their wings. These wasps have a keen preference for spider eggs. They are often found feeding on the medium-sized eggs of common spiders. Their slippery-haired wings allow them to slip through the silk strands of the spider egg sacs that are stored in leaf litter by spiders. Each wasp has a uniform length of 1 to 2 mm and are found in clusters. The discovery has inspired biologists to yield large number of parasitoids to destroy spider eggs.